Hey, Fernando here. I'm going to be talking to you today about my Sparkfun project, the colorful keyboard. At first when I was kind of deciding what to do for my Sparkfun project, one of the first things that came to my mind was the buzzer, because I personally enjoy music, and I think it's a great way of communicating things. And so I picked the buttons and the RGB as the two other functions because I think they interact in a great way. You press the blue button, you get a blue light, and you get a certain frequency from the buzzer. And even though this is targeted towards a much younger audience, I personally find it enjoyable, and it can act kind of as a stress reliever, which is great. So now looking at my project, this is kind of a bird's eye view. You guys can kind of get the idea. There's a lot of wiring, which is fine. So looking first at the buzzer here, we have that it's got a negative side on the positive side. The negative side is connected to the ground section on the breadboard, and then the positive side is connected directly to the breadboard. Then we have the 4 different buttons here. We have that each button is grounded to the breadboard, and is connected directly to the breadboard. Each individual button has a 10k ohm resistor. And then lastly, looking at the RGB here, it has 4 different legs. The second leg is for the ground section on the breadboard, and the other 3 legs are connected directly to the breadboard. And each individual leg has a 330 ohm resistor. So yeah, and then here on the far left, these are just the 5-volt source and the ground section, which are connected to the individual sections here on the breadboard. Okay, so now let's kind of talk about how it works. So we have the buzzer here, the 4 different buttons, and the RGB. So looking at the buttons here specifically, the reason I kind of chose this order of colors is because when we look at the color spectrum, there's different wavelengths for each color, and blue in this case would have the lowest wavelength, and red would have the highest wavelength. And so to each button, I attributed a certain frequency, and so in this case, blue would have the lowest frequency, and red would have the highest frequency. So we can kind of hear it here. And when you press them all together, you get that white color and a much higher frequency, which is basically just adding up all the different frequencies. And originally I had it planned so that each button would play its own song, but because this is targeted towards a much younger audience, they would kind of want to just play around, with each button, and they wouldn't really listen to each specific song. So with this, they can kind of create their own songs. They have the freedom to play whatever they want to. It doesn't just play one song. So looking at the code side of things, kind of just wanted to show you guys how it works in Arduino. And so basically up here we have the constants that define each part of the program. And so basically we have the red, green, and blue pin, which are from the RGB, to certain numbers on the breadboard, the buzzer, and the 4 buttons. And so in the setup, we would say we're defining what each pin is. So obviously we have the RGB as outputs, and the buzzer as an output, and then the buttons as inputs. Now looking at the loop, and basically here's where everything kind of works through. And so we say, like, for example, if the red button is the only one that's being pressed, then the red pin is the one that's only supposed to light up, so the RGB would light up red. And then one last condition for just when nothing is happening, obviously nothing is supposed to output. So yeah, just so you guys kind of get the general idea. I'm glad you guys stuck through to the end of my video, and I hope you enjoyed it. And as always, thanks for watching.